Hi, you guys. We're going to talk about the three states of matter and the energy or the heat required to change between these three states of matter. So as you guys know, or you should know, that the three states of matter are solid, liquid, and gas. You've most likely heard that before. When we're going from a solid to a liquid, we call that the melting temperature or the melting point. If we're going the other way and going from a liquid to a solid, we call that the freezing point, and that's known as freezing. And notice that these are going to occur at the same temperature. Okay, so for water, going from a liquid to a solid is going to happen at 0 degrees Celsius. And also to go from a solid to a liquid is also occurring at 0 degrees Celsius. And the difference between whether it's going to go from a solid to a liquid or a liquid to a solid, it's depending if heat and the energy is going into the system or out of the system. On the right, we see liquid going to a phase change of gas. And when we go from a liquid to a gas, we call that vaporization or boiling. And that temperature is going to vary on the pressure, what kind of pressure is on the water. And then going from a gas to a liquid is called condensation. Now we can also go straight from a solid to a gas, and we call that sublimation. And we can go the other way, straight from a gas to a solid, and we call that deposition. All right. So you may know some of these properties of solids, liquids, and gas. Most interesting is that when you're a solid, you're a rigid shape. It's a fixed shape. It doesn't matter what container you're in, right? You have a fixed volume. Liquid, it's not rigid, right? It doesn't have any of this fixed shape. It does have a fixed volume, but it's going to assume the shape of whatever container you put it in. So like if you put water in a round glass, it's going to assume that round shape. If you put it in a square glass, it's going to assume that square shape. And then gas is also not rigid and doesn't have a fixed shape, but it also doesn't have a fixed volume. So not only will it adapt to whatever shape your container is, but it will spread out to the maximum volume of that container as well. And this is just some idea. When you're in a solid, you kind of have particles close to each other. Liquid, they're moving around, and gas, they're moving around even more. I have a different video on this. You guys could watch it in your top hat lesson. Okay. So yes, when we're going from a solid to a liquid, we got to gain energy, usually in the form of heat. And if we're going to go from a liquid to a gas, we're going to boil water. We also are going to gain energy in the form of heat. And if we're going the other way, where we're going from a gas to a liquid, heat is lost, energy is lost. And going from a liquid to a solid, energy is also lost. And again, that's in the form of heat. So in this case, in going from a solid to a liquid, we call it the heat of fusion. And the heat of fusion tells us the amount of energy, the amount of heat that's gained either during melting or the amount of heat that's lost during freezing. And we have this equation, Q equals M times delta H of fusion. So Q is our heat in calories. Sometimes it's in joules as well. So just make sure you're paying attention to units. M stands for mass in grams. And delta H of fusion tells you the heat of fusion. And usually this is in calories per gram. So you get this from a table, okay? So the heat of fusion for water tends to be higher than most common substances. That is true. Okay, now in going between liquid and gas, the amount of heat gained either during vaporization or boiling, or the amount of heat lost during condensation is given by that heat of vaporization value. And it has a very similar equation to the heat of fusion. So again, it's just Q represents our heat, again in calories or joules. M is our mass in grams. And delta H of vaporization is just the heat of vaporization. And again, usually in calories per gram. That's what I gave you on our top hat course, okay? The heat of vaporization for water tends to be higher than most common substances as well. Okay, so we can do lots of interesting calculations with this information. I want to be really clear here that this is a calculation only for the phase change, only if we're changing from solid to liquid or liquid to gas, or the other way, gas to liquid or liquid to solid. There's no change in temperature here, only a change in the phase, okay? So it's telling you the heat of vaporization of water is 540 calories per gram. The heat of fusion of water is 80 calories per gram. So there's a little bit of test here. Do you know which one to use? Okay. So the question is asking how much heat in calories will be needed to boil 750 grams of water. Pay attention. We are boiling. So we're going from a liquid to a gas. So that tells us, you know, which one do we have to use? Are we supposed to use our heat of vaporization or our heat of fusion? Think about it. We're vaporizing, right? We're boiling. So here we want to make sure we use that value for heat of vaporization. So we would take our mass, and remember Q, which is heat, which is what they're asking for here, is the mass, so 750 grams, times that heat of vaporization. And this heat of vaporization is 540 calories per gram. Notice grams will cancel, and you end up with 405,000 calories, okay? Or you could say 405 kilocalories. Remember that prefix of kilo, it's a factor of 1,000. So next question, how much heat in calories will be needed to melt 475 grams of ice? Again, it's just asking for a phase change, right? It's only asking, we're only melting the ice. That's it. We're not changing the temperature. We're just taking it from solid to liquid. No, that's the first thing you really need to pay attention to. Second thing is, do we use our heat of vaporization or a heat of fusion, right? We're going from a solid to a liquid. That involves fusion, okay? So we gotta make sure we use this delta H of fusion up here. So when we do this problem, again, it's our mass, 475.0 grams of ice, times that heat of fusion value, 80 calories per gram. That gives us 38,000 calories. It can also be reported as 38 kilocalories.